Hello, my name is Gustavo Sais Cruz. I'm a second year physics and mathematics undergraduate at Purdue University, and today I want to take a critical look at the existence of a fifth force. The standard model of particle physics is the most successful theory we have for describing the universe as it is. However, recent experiments have given us reason to believe that new physics may be on the horizon, as how we think particles should behave and how they actually behave have kind of drifted apart a little bit in this experiment. Uh, in this experiment, I first learned about in a paper titled "First Results of Fermilab's muon G minus 2 experiment: Strengthened Evidence for New Physics," written by Tracy Mark and published on Fermilab under Fermilab. But first, let's take a look at what the standard model really is. So here we have kind of like the periodic table for particle physicists. So here we have all of the particles that we know about. So we have quarks on the top left, we have leptons on the bottom left, and we have bosons on the right. Now, all of these particles have different properties. The quarks kind of like to be together. They like to be by other quarks. Well, the leptons are okay with being alone. You can find them by themselves. Well, you can't really do that for quarks. And bosons are completely different altogether. They mediate three of the four fundamental forces. So because of bosons, we have electricity, magnetism, uh, and we have atoms and radiation. So a recent paper published on the APS journal by the muon G minus 2 collaboration titled Measurements of the Anomalous Precession Frequency of the Muon in the Fermilab muon G minus 2 experiment suggests that we might not understand particles all that well because, well, let's see here. So the experiment measured the precession rate of muons. Now, however, it got a completely different result than what we thought would happen given the standard model. So the standard model gives us a little prediction for what we think should happen, and the experiment gives us another prediction. Because the standard model has to be the most precise theory we have, we see a problem here because it's not. So what are we talking about precession and spin here? Well, particles kind of act like little magnets. So they spin around their axis, and this makes them like little atomic uh, magnets. The BBC article titled "Muons: Strong Evidence for a Fifth Force of Nature," written by Palab Ghosh, describes it as wobbling. So he says that they kind of wobble. So they spin, and as they spin around and move around, they kind of wobble a little bit. So you can imagine this little axis spinning itself as well. So it kind of wobbles. So what we saw is that in the experiment, we put a lot of muons when we sped them up at close to the speed of light around the little circular loop. And we measured this wobbling and found that the value of wobbling was actually higher than what the standard model predicted. Now, many people say that this is evidence for a fifth fundamental force of nature. And while a fifth fundamental force of nature could fix the predictions made by the standard model, I think that a more likely theory is the existence of a new particle. So new forces, if a fifth force did truly exist, it would mean that we have not detected it in decades. In the decades we've had Fermilab and the LHC. So we have had laboratories such as Fermilab and the Large Hadron Collider that have measured subatomic events, that have measured like small quantum events at a very high precision. However, this would mean if a fifth force existed, this would mean that it has gone undetected despite our large technological advances. Another reason why a fifth force is unlikely is simply because of Occam's razor. So Occam's razor says that the simplest explanation is the most likely. Now this means that it is much simpler to say that a new particle exists, than to say that a new force exists. Forces are much more complicated than particles, and they require a lot of theory and a lot of thinking behind them. Well, a force while interesting, it's much simpler and more self-contained. So, in addition, there are many theories and many hypothetical and theoretical models that predict the existence of different forces. Gravity cannot be explained by the standard model. However, physicists are working towards a quantum theory of gravity, a so-called quantum theory of gravity that sort of like takes into account gravity. This theory has the existence of new particles. Another famous theory, supersymmetry, predicts a plethora of new particles, and string theory also predicts several new particles as well. This means that new particles is much more common than new forces. There's only 4 forces while there are 17 particles. So we can clearly see that particles are more favored when it comes to discoveries. And this leads us to believe that it is more likely that a new particle has been discovered, or that there's more reason to believe that a new particle exists rather than a fifth force. So in summary, the standard model is extremely accurate. However, we have made predictions about what we think should happen, and what we have actually found was completely different. And so this leads us to believe that may have a avenue to discovery in the near future. However, many people say that it's a fifth force, the result of an undiscovered fifth force. However, it is more likely that it's just a new particle. Thank you very much.